Hi class, it's Bill here, and we are continuing with our review of object-oriented programming basics and getting familiar with IntelliJ. Remember last time we left off, we had finished up our bank account class, so we think this part is all taken care of and in good shape. Now we need to work on our bank class. So you'll notice that we are going to start with a couple of instance variables here. We're going to have accounts and we're going to have our interest rate, and then we'll continue coding there. And we'll also explore has-a relationships and review our knowledge of those. So to get started, we know that we need an interest rate, so we're going to have an interest rate instance variable, and then we talked about wanting to have a list of accounts, right? So we know that that's going to be necessary. The way that we probably want to do this is that we're going to make an array list, and remember array lists are generic. That means they need a type parameter, which in our case is going to be made up of bank accounts, right? So it's going to be an array list of bank accounts. We will let IntelliJ, I'm going to press the magic key, Alt Enter, and you notice that it automatically does the import, which is swell. And then we're going to call it, let's say, accounts. Let's make sure that that's exactly what it's supposed to be. I think that is right, but let's go back and just verify accounts and interest rate. Yep, that looks right. All right, so notice the way that we know that this is a has-a relationship is because we use this name. If somewhere in the class bank there is a reference created or multiple references created that are of bank account type, right, where the static type is bank account. Now that doesn't mean that you have to instantiate the bank accounts here. That may or may not really be happening, right? But there are references here that are maintained, whether that's in an instance variable as a parameter to a function. It doesn't matter where. If for even a fleeting moment you have a reference to an object from another class, that's a has-a relationship. Another name for that is composition, right? There's no inheritance here. You can't say a bank is a bank account or a bank account is a bank. That makes no sense. Inheritance doesn't belong here. Don't confuse that. This is not an is-a relationship. This is a has-a relationship, which is also called composition. A bank is composed, at least in part, of bank accounts, right? So don't confuse the two things. So since we have used this word here and it is in a declaration, right, not necessarily an instantiation, maybe we'll do that, maybe we won't, then we do have a has-a relationship. We also are going to certainly want a constructor, so we're going to have public bank. And then we're going to say what goes in there. Let's go back to our UML class diagram. That's going to be the interest rate, which is the initial interest rate, which is going to be a double. So we're going to have interest rate, and that's going to be a double. So we do that, and then for the moment we can just say this dot interest rate equals interest rate, right? Great. So we have our constructor, and also notice that we'll probably go ahead, since we have our array list, we probably want to go ahead and create that array list here as well. So let's go ahead and make that thing. So let's say accounts equals new, and it's going to be array list, and the array list is going to be, in this case, that's probably fine. Remember, you can use diamond notation, which means you don't have to put a type here. It will infer it from the static type, from the reference, or if you want to be complete, you can certainly say that, right? You can use the whole word if you like. So now in our constructor we've done that. Now you could say, well, why don't we just put this stuff up here? Why don't we just do the instantiation here? Interestingly, the declarations have to go there because they are global, right? There's nowhere else for us to put global variables like that. But if you have code like this where you're instantiating something, this code, regardless of whether you put it here or here, is actually done in the constructor. So if we had said equals new array list, that code is actually down here anyway. It looks like it's happening there, but the only place for it to actually happen is in fact in the constructor. So if you looked at the bytecode that results from our compile, you would see, oh no, it is actually in the constructor. So my preference is not to actually instantiate and bind out here, because we don't want to tell our brains that that's somehow happening outside of the constructor. It is not. It's in the constructor code, no matter how you'd look at it. So I like to put it here, right? I don't like to do the declarations and binding. Declarations, yes. Instantiation, binding, I don't tend to do there. All right. Now let's see what else we need to do here. Let me just copy and paste some stuff. right? I'm going to copy and paste from the UML, and then I'm going to maybe just mark it out. So I'll just come down here and I will comment that out. So we just have a little list of work items here, and then we can start going through it. All right, so we know we need a get method, get account. That's misspelled in the UML, and notice that our spell checker here is actually helping in both cases. Wow, it's helping us find out that we have errors in our spelling in both cases. That's great. Okay, so the easiest way to make the get method, I can just click on this thing, and then I can do Alt Enter, and I'm going to, oh, and of course, don't forget here, these are going to be private, right? So don't forget to mark everything as public and private. Now when we do our context actions, Alt Enter or right click, I can say create a getter. And do we want a setter for that? It appears that we do, so I can again do this, and I'm going to, let's see, what else can we do? It could probably have done both of them at the same time. Will it let me do it here? It doesn't, so that's okay, right? That's okay. So we'll do public void set interest rate, and here we have to do a new interest rate, right? And we want to say this dot interest rate equals interest rate. All right, so again, we'll come back and we realize here we've got some issues. Right now we can already take care of the fact that there's duplicated code on line 9 and line 18. So why don't we just take care of that now? Why don't we call set interest rate? We'll pass along the thing that came into us as a parameter. That way we know that when we go to do our to-dos, right, to do preconditions, we know that we can put them in one spot and not worry about it. All right, so that all looks pretty good so far. All right, so that takes care of get account, and that takes care of, oops, it didn't take care of that. And then it probably, we want to say set interest rate, we've taken care of that. Great. So next thing we want to do is take care of this, where you give me an ID and I give you back a bank account. Notice, as often as possible when we're doing object-oriented programming, we want to speak in object references rather than the raw materials for the object references. So here, for instance, when you say open account, you're going to pass in an account. You're not passing in the raw materials, and I have to make that, right? I have to instantiate it. Why? The client has just as much access to bank account as you do. So let them make the account and pass that to you. Don't take on responsibilities that you don't need to. But in this case, we like the idea of, hey, you give me the ID and I'll look that up for you, right? So in this case, let's take care of that one. That's a pretty straightforward one. And maybe we're going to provide a couple of those, right? We might have one where you give me the ID, but we also might want another one, and our UML ought to reflect that. So for instance, maybe we want to say public bank account get account. And notice in our case, the bank is acting as a collector of bank accounts, right? The bank is holding that collection. When you are a collection manager, you have some responsibilities to allow access to that collection to some limited amount. So certainly maybe you give me a string of an ID and I go find the account and bring it back, but probably, and I'm just going to stub this for the moment, return null, right, just to make it compile. But you may also want one like this, right? This would make some sense. Get account, and maybe we make an overload where we give the index, right? We say, what's the index of the thing that you want? And then I'm just going to pass through a get call to that. So I'm going to return accounts.get, and I'm going to pass through that index, right? So that's an easy one, right? Hey, you tell me the number, the index of where in the list you want me to get the account, and I'll just give it back. Notice that here we do not need to do a precondition check because Java already has that covered. The Arraylist class knows exactly what to do if you try to ask for something outside the range, right? So we don't have to do anything about that. It'll throw the exception, we'll get whatever's right. So we don't need to do any preconditions. Don't duplicate code, right? That's one one of our guiding principles. And don't duplicate Java's code either, right? If Java already takes care of the task, why would we do it, all right? Up here, maybe this is a different matter. If we want to get an account, we're going to have to now go look through those things and see if we can find one, right? So maybe we need to make a loop that goes through these things. We could write a for loop or a for each loop, and we could go and look for that thing. So we could do this in a couple different ways. We can write a for loop. We can write a while loop. Technically, the while loop feels righter because when you find the thing, you're going to stop. But it also requires a lot more code, right? The code actually gets more complex. So maybe a for or for each loop is exactly the thing that we want, right? So I'm going to write a for each loop because I think they're very clever, right? So for each bank account, right? That's the data type of the thing in the collection. So I'm going to say, one account in, and then I'm going to say accounts, right? So for a for each loop, I'm going to first put the variable that represents the type of each of the elements, and then I'm going to give a variable name, and then a colon, and then the thing that is actually the collection that I'm searching through. And then I can write an if statement that says if in that one account, whatever that reference is pointing to right now, get account ID. And then remember, that's a string, so I can't use equal equal. I have to say this, and I have to say ID here. Oops, that's not what I wanted. Where did I go? Okay, where was I? Okay, then, right, if the ID in the account that I'm looking at in the loop equals the ID of the thing that was passed to me, then I have found it. So I'm going to return that account, one account, right? Just return that reference. Otherwise, if I get to the bottom and I'm through with the loop and I haven't found it, what am I going to do? I would guess probably we are going to return null, right? That would make the most sense because notice the return type is bank account, so that makes sense. And so since that's an object, the obvious thing for, hey, I didn't find it, is going to be null because you don't have an object to pass back, right? An object reference. Now, some would say, hey, this is kind of a lie because you've made it look like you're going through all of the list, but then you've returned in the middle of it, right? So that's not necessarily the greatest thing in the world, but the most important thing is, will a reader see that return? Will the reader be clear that you're returning in the middle, right? It's not completely true that only one return at the bottom is allowed. That's not kind of a real world scenario. You can return in the middle, but the important rule is don't bury it. Don't make it hard for your readers and for you later to see the fact that you actually did bail in the middle of this loop. So in this case, I think we'd allow it because if I showed you the other version with the while loop, there's a lot of logic in there. Right? There's more logic and it actually makes things more complicated. So I think we're okay here. Right? Now we still do have preconditions, right? To do. So preconditions, we'll come back to that, right? So you get the idea here of what we're doing. We want to be able to open an account, so let's take care of that one quickly before we wrap up the video. Right? So public void public, if I could spell today, public void open account. So if they want to open account, what do they have to pass us? They have to pass us a bank account, right? They just pass us an account. Again, don't say, when you want to open an account, you have to pass in all the raw materials. You don't have to pass the ID and the owner's name and the balance. No, that's elsewhere, right? That stuff's already taken care of. That's why we have the bank account class, so that you can instantiate, and any client code can instantiate that as easily as you can. So don't speak in raw materials, speak in objects, right? Object references. So this is actually really easy. All we have to do is say accounts.add, if I could spell accounts.add, and add that account. Right? Now you could argue maybe we need to go through and make sure we don't already have something with that number. Sure, that's something that maybe to do. Maybe that's a question whether we should ensure no duplicate IDs. Right? That's something to ask the program manager. Hey, did you think about this? Is that something that we need to do? Yeah, probably we need to. But yeah, let's not worry about that too much. And of course, we also have our usual to-do on preconditions. Okay, so if you want to open an account, then that's great. Okay, if you want to close account, then what do you have to do? Close account, you tell me that, right? And then in this case, it's really easy to close an account because we can do this just by saying remove, right? We can use the Arraylist remove by object reference, and it will go do it. If it can find one, it will remove it. Again, and we could think about, does it remove all of them? If there are two with duplicates, which we probably don't allow anyway, do we really want to just delete it from the array list, or is there some more official procedure of backing it up to some other list or whatever? I don't know. But for the easy part of it, that's really straightforward, right? And then we have some other methods that we wanted to have. We've done get account and open account and close account. Oh, this one's kind of interesting too. Does this remove call return something? And notice it does, because there is a Boolean return, and it says, let's see, throws returns. True if this list contained the specified element. Right? So we could actually return this as an additional little signal, right? So we can return a richer result by saying, hey, accounts.remove will actually tell us whether it really removed the thing or not. So we might as well pass that through back to the client so that they can they can do something with that if they need to. So that's great. All right, so there's a few other things that are here that I don't think are as interesting to code. Get total balance would just go through the whole list and add up all the balances and return them. That's going to be a loop that's going to look a lot like this, maybe a for each loop. And so we could certainly write those, and I think we will forego that for the moment, and I can just paste those in, and then we won't walk through that together. So I will paste those in before we do the next video. We do need to do some preconditions, but we're getting a little bit long in time for this one video. So I'm going to stop it here, and then we will resume in the next video, add our preconditions, and get this particular class all tidied up. See you next video.